How's everybody doing? Morning. Hope everybody's having a good day. I am. I'm teaching my kids, and then I'm teaching you guys. It's a pretty fun time. Uh, Remember what we're going on. Don't forget, everybody, if you're watching this, let's say it right off the bat. Don't forget to take attendance. Make sure you sign into your attendance today. Also, remember, we will have a final. The Harper final is 15% of your grade. So don't forget, after we're finished with this unit, this is our last unit of the year. Once we finish with this unit, then we're going to have the Harper final. We're going to study for that. Also, what was I going to say? Oh, yeah, don't forget that there's a quiz tomorrow. And you have to take that quiz tomorrow. We'll post it up tomorrow, and you should be good to go. Okay? So, a lot of good stuff going on here. Let me make sure we are all doing well. Yep. All right. So, let's take a look. We have a couple sheets today. Take a look at it. Hey, remember, let's just review. Let's refresh some memory here. Remember what we were working on? We were working on exponents. We're working on exponents, okay? And when we're working on exponents, the formula is y equals a times b to the x. A is the coefficient, okay, and that's the y-intercept. B is the rate of growth. That's the base. B stands for the base. And remember, the rate of growth, there's a couple different conditions, just like slope with y equals mx plus b. When you got y equals mx plus b, if the slope is negative, it's decreasing. If the slope is positive, it's increasing. Well, same thing here. Okay, if b is between 0 and 1, remember, b can't be negative. No negatives. If it's between 0 and 1, it's called decay, and the graph of decay starts up high and goes down low. And if b is greater than 1, that's growth, and it starts low and goes up high. This is growth. You see what I mean? That's the idea. We got our y-intercept, we got our decay and growth. Now remember the change. The change, I spelled change wrong. Change is times or divide. Okay, it's not adding or subtracting like it was for slope. 2, 7, well, I added 5. 12, I added 5. That's slope. Here, it's 2, 10. I multiplied by 5. 50. You see how fast that could start growing? Okay, now remember, we also had a word. Let me add it in here. Okay, when you draw your graph, it cannot cross the x-axis. Okay, this is called a horizontal. This is a fancy word. Asymptote. I think there's a P in there. Asymptote. I think I spelled it right. Asymptote. Horizontal asymptote. That cannot cross the x-axis. You see that? So if it comes down, it's like a magnet. It's coming down, coming down, coming down. And you know how you try to push two magnets together and they kind of force one way or the other? That's what this does. It comes down and forces it to go this way. You see, that's a horizontal asymptote. Okie dokie. So, that is what we were talking about. Let's review just a little more. Okay, take a look at our situation here. Okay, we have 2 get you -4. I'm sorry, -2 gets you -4. -1 gets you -2. Okay, and let's look at the change. Okay, you could think, oh, okay, wait a minute. I'm dividing by 2, but 2 divided by 2 is not 0. So dividing is out. It's getting smaller. So let's try subtracting. -4 minus 2 is -6. Oh, that didn't work. Let's try multiplying. -4 times 2. Okay. -4 times 2. No, that's not working. How about add -4 plus 2? Oh, okay. Plus 2, plus 2, plus 2, plus 2. So is this relationship a function? Yes. And what type of function is? It's linear. It's a linear function. Because I'm adding 2 every time. Remember, linear is lines. I'm adding 2 every single time. Okay? Fill in the table below with the inverse. Now remember what the inverse was. Let's review that word right there. It hasn't been a while. An inverse, you switch the x and the y. Okay, that's your first rule of inverses. Inverses, you have to switch the x's and the y's. So if the x is -2 and the y is -4, then we switch. -4, -2. -2, -1. 0, 0. Oh, that's nice. They were the same. 2, 1. 4, 2. You see what I mean? You switch the x's and the y's. That's the inverse. Is this a function? Okay, let's see. Let's see the change. +1, +1. All right, that's fine. That's fine. +2. Oh, we got a rate of change. We got a slope here. +2, +2, +2. So that looks like it's another linear function. But it's 1/2. You see, this was change of 1. So this is 2 over 1. Well, this is 1/2. Now, how do we remember it's a function? Remember, you cannot repeat. Okay, a function, when -2 is -4. And every time -2 will be -4. If I come across -2 again, it's not -4, not a function. These are linear functions. Okay, remember, inverses, you switch. That's the key thing for today. Inverses, you switch the x's and the y's. Okay, don't forget about that. How about this graph? Does the input have a unique output? Okay, so remember, input is the x, output is the y. Okay, so for every time, visually, how do we tell this? Visually, when I say, I don't know, x is 3, is there only one y value? That's what it means unique, only one of them. Does the output y have a unique input? So for every y, when y is 3, does it have only one x value? Okay, let's do an example of that. What if I was looking at a parabola? Let's look at parabola. Okay, when x is 3, look up. Yeah, there's only one y value. But when y is 3, oh, look, there's 2 possible values for when y is 3. When y is 3, remember how we had that? You could have 2 possible values. We could have it that side and that side. We talked about symmetry and all that kind of stuff. So there's an example where each output does not have a unique input. Okay, this is all for inverses. Here we go. In this case, when the inverse relationship is a function, it would be nice to have a formula for the inverse. Then, to the harder question about the input leads to a particular output. We could just say that the inverse relation and answers are easier questions. Let me explain what they're talking about. They're talking about inverses. And the symbol we use for inverse right here is f to the -1. Okay, f inverse, we say. Okay, f to the -1. That's the symbol we use, that the two functions are inverses of each other, that the two functions switch the x's and the y's. Okay, now remember, visually, when we get to functions, what's an inverse? What's the opposite of add? Subtract. What's the opposite of multiply? Divide. Those are inverses of each other. What's the opposite of square root? Square. Those are inverses of each other. Let's take a look. All right, so take a look at this situation here. These are inverses of each other. You see the symbol? F inverse. Okay, so if this is 2, 4, -2, -4, the switch should be -4, -2. If this is -1, -2, we switch -2, -1. You see, all it does is we switch the x's and the y's. Well, 0, 0 is still the same. 1, 2 gets you 2, 1. 2, 4 gets you 4, 2. Okay, so let's see if we can read the chart. F of 2. This is f. F of 2, we look. F of 2 is 4. So right away, now I know the inverse at 4 is 2. They switch. That's the symbol. You see, we switch. Take a look. Here's the inverse function. At 4 is 2. But the inverse at 2 is 1. You see? So that's not going to be the same. What's going to be the same is the switch. Those are inverses of each other. And that's the property that we're talking about right here. If you have a function and A gets you B, then the inverse function B gets you A. The x's and y's switch. You see what I mean? That's the key. The x's and y's switch if they're inverse functions. If their functions are inverses of each other. Does that make sense? Okay, so let's look at an example. The C is the cost to produce X items. So what does this mean? Okay, to produce, you see, if we want to produce 50 items, it costs $12,000. You see the words? C is the cost, 50 items. X is the item. So X is 50 right here. Here's X. So to produce 50 items, it costs $12,000. Okay, well, whereas the inverse, look at the inverse. The inverse switches the X's and the Y's. Okay, so it costs, see, we're switching. Produce, we start. Now we're going with cost. It costs $14,000 to produce 60 items. Okay, take a look. Let me change colors here. Produce, cost, dollars, items. Okay, you see? Or I should say cost. So the produce items, here's your, let me underline that. Produce items, switch to cost. Cost, switch to items. You see how inverse, we switch the X's and Y's. That's the point we're trying to make. The X's and Y's switch. So on here, okay, remember, you could always pause the video, and at this point, like if you're stuck, if you're like, Mr. No, I'm not getting what that is, send me an email. Okay, it'd be nice if you were here online. There's only like 12 people watching right now. It'd be nice if you were here, but send a message. Put a message in there and say, hey, this is where I'm confused at. You know, we always do this at 9:30 every day. All right, let's take a look. We did this before. I plug in 0, maybe a calculator. Maybe use your calculator here or do it by hand. I plug in 0. That's the y-intercept, so right away that should be 32. I plug in 1 is 16. I plug in 2. It's 8. Notice we see a pattern. I plug in 3. It's 4. What's the pattern? Dividing by 2. I plug in 4. It's 2. See our little pattern here? And so the inverse, we switch the X's and Y's. That's what I keep saying. 16 gets you 1. 8 gets you 2. 4 gets you 3. 2 gets you 4. We switch the X's and Y's. So those are inverses. I plug in 2. Gets me 8. Inverse, F inverse, F of 2 is 8. F inverse of 2 is 4. Notice they're not the same. But let's do an extra one. If I know F of 2 gets me 8, then I know the inverse at 8, which is not on my chart. Oh, it is on my chart. Gets me 2. See right there. Let's do one that's not on the chart. Okay. If I know, for example, well, the charts match the same. Let's do... No, it's on the chart already. We'll find one that's not on the chart. Okay, but that's switch the X and Y's, and then you could read the table. Is everybody doing okay there? Just checking the messages. All right, let's keep going. Okay, talking more about inverses. Put your socks on, put your shoes on, tie your shoes. That's the plan. That's how we got to do it. That's how we do it. So inverse, as we said, is the switching, the undo. We work backwards. So the inverse would be tie your shoes, put your socks on, put your shoes on, and then put your socks on. Think about it like this. Okay, in the morning, you put your socks on, then you put your shoes on, then you tie your shoes. So in the night, you're doing the inverse. You're doing the opposite. You tie your shoes. I'll write the whole thing. Tie your shoes. You untie your shoes. You unput your shoes on, and then you untake your socks off. You can't take your socks off without untying your shoes and taking your shoes off. So that's the undoing. That's the opposite. That's backwards. That's what an inverse is. It's opposite. It's undoing. Okay. How is the sequence undoing? So we talked about that. Let's do a math problem. What do you do on this? You got an X. I plug in 5. What do I do first? Order of operations. Okay, I times by 2, and then I add 4. Okay, so what's the opposite? Now remember, the opposite is not divide by 2. We go backwards. So instead of reading left to right, we're reading right to left. So the opposite, minus 4, and then divide by 2. Now that's important. You see, put your socks on, put your shoes on, tie your shoes. So tie your shoes is now first. So This is first. And what's the opposite of plus 4? Minus 4. What's the opposite of tie your shoes? Untie your shoes. What's the opposite of put your shoes on? Take your shoes off. What's the opposite of put your socks on? Take your socks off. That's the opposite. Does this make sense? Check the comments. Say something if you're stuck on something. Okay, so let's look at the order of operations. Look at how these are inverses of each other. I put in a 5, I multiply by 2, then add 4. Well, I put in a 5 here, I subtract 4, and then divide by 2. Okay, so for example, I plug in negative 2. I plug negative 2. 2 times negative 2 is negative 4 plus 4 is 0. Let's do this one. I plug in 0. 0 minus 4 is negative 4. Divided by 2 is negative 2. Oh, look. The x's and y's switch. That's the whole point. Negative 1. 2 times negative 1 is negative 2. Plus 4 is positive 2. Oh, look. I plug in positive 2. 2 minus 4 is negative 2 divided by 2. Negative 1. The x's and y's switch. They're inverse to each other. How do I recognize they're inverse to each other? This has times and add. So this has minus and divide. Remember we used to do the tables here? If I say x and you say times 2 and then you say plus 4. And so now we work backwards and we working up this way. Minus 4 divide by 2. That's the inverse. We never called it the inverse, but that's the inverse going backwards. So if I know this one is 4, hopefully you see the pattern by now, 6, 8, to plus 2, plus 2, plus 2, plus 2. Going this way, if we switch, here's the inverse. Minus 1, look at this one, over 2. Minus 1 over 2. The slope is 1/2. Those are inverses of each other. They switch the x's and the y's. I keep saying that. That's what an inverse is. All right, so let's do a little example problem. Okay, here's a function. Okay, the number of worldwide emails sent a day in billions, t years. Okay, t is years, and this is f is how many inverses. Okay, so what do we got to do here? Since I said 2015, I plug in a 15. What would I do if I plug in a 15? If I plug in a 15, I multiply first, and then add. So if I make my chart, whatever I'm plugging in for my x, I multiply by 12.1, and then I add 14. Okay, so let's work our way backwards. Minus 14 divided by 12.1. So the inverse function, f inverse of x, is take your x, you minus 14, and then you divide by 12.1. You see how I did that? I just do order of operations, and then backwards is the inverse. So f of, now we've got two functions, be careful, f of 15, 12, I'm using this one, times 15, plus, sorry, that's decimals, I'm going to use my calculator, 12.1 times 15 plus 14. Okay, now what does this mean? F of 15 is 195 now remember what that means. 15 is years after 2000. So this is 2015. So in 2015, this is how many billions of emails sent. Let's do this one. Okay. F inverse of, now let's in content of the problem. Going backwards. In 2015, this is how many billions of emails sent, so we're going backwards. Billions of email is in what year? So I plug in minus 14 divided by 12.1. Let's see what happens. Make sure on your calculator. Minus 14. Don't forget to hit enter for the top. And then divide by 12.1. And this is 16.2, let's say. What does that mean? What year? Remember, we're backwards. This is billions of email. This must be years. So in 2016, a little bit January, February, March, 2016, there was 210 billions of emails sent. What's the slope? Okay, what's the slope here? Rate of change is okay, plus, we'll do over 1. What does that mean? The rate of change. Remember, what's this? Units. Okay, look at our units here. T is change in Y over change in X. Y is billions of emails. T is years. My boys are playing dodgeball upstairs, apparently. You see that? Billions of emails per year. There's our Y's and X's. Okay, so always do that. Okay, there's the Y. So it was billions of emails, and there's the X. So it's Y, change in Y over change in X. Whereas this going the other way. Okay, this is opposite, reciprocal. Think of it like that. 1 over 12.5, and this is years. For 1 year, every year, this is billions of emails. Remember, the reciprocal flips over. Did that make sense? Okay. How is that? Feeling okay there? This is a tough concept. We're just doing some examples here. Let's do another one. What's the inverse? All right, again, make your chart. You should be able to do this one on your own. Pause the video, do this one on your own, and then take a look. Order of operations. 3. Order of operations here. And then minus, see, I'm going backwards. Divide by. Do order of operations. Here's my chart. If I was plugging in 50 here, I'd multiply by, and then I would add. So I'm going backwards. So our inverse is the backwards. The inverse is take your X and you minus 74,400 and you divide by. Let's take a look at what this means. This equation predicts the value of a house in Hawaii X years after 1950. So years, X is years, and F is the money. Okay, so if X is years, so 70 years after 1950, well, let's add 70 to that. So this is in 2020, that's this year, the value of a house in Hawaii, let's see what it is. F of 70 is 39, I'm going to use my calculator here, times 70 plus 0. Let's see what we got. 3966 times 70 plus 0. And the value of the house is 352,020. 352,000. Okay, so what's this inverse mean? Now again, look at the slope of this. The slope is change in Y. Okay, so the dollars, the cost of the house, change in Y over change in X years. So dollars per year. So the inverse is the opposite. If I'm plugging in the function of I'm plugging in years and getting money, here I'm plugging in money and getting years. In other words, when the price of the house is $233,000, what year did that happen? You see, it's just the opposite. It's like we're solving. So I plug that into the equation. Divide by, now remember on your calculator, don't forget to hit enter. That's what people mess up the most. 233,040 minus 74400. Okay, there's your number. And then you divide it by 966 and 40. So I got 40. What does that mean? 40, interpret the problem. If the 0 is 1950, this is in 1990. You see what I mean? It's like we're solving. That's what the inverse does. So, what's the slope? Inverse, years over dollars. Which in our case, if the slope of the previous one was, if this was $3,960 per year, this is 1 over whatever number that is, years per dollar. For every year changed, this is how many dollars it changed. Whereas this is for every dollar it changes how many years it takes. How's that? Feeling good there? All right, let's do one more example. Let's do two more examples. I think I got 2 more pages here. Let's do a couple more examples. Okay, here's example 3. Determine if there is an inverse. Now remember what an inverse looks like. Let's put this note back here just to refresh your memory. Okay, the vertical line test was a function. Remember we did the vertical line test. Remember we had a circle and we said, is this a function? No, it's not a function because the vertical line test, if a line crosses more than one point, not a function. Well, the horizontal line test, okay, the horizontal line test is for inverses. If it passes the horizontal line test, then it has an inverse. For example, horizontal line. Can you draw a horizontal line? Let's move our pen. Can you draw a horizontal line anywhere here? Anywhere here, can you draw a horizontal line that crosses more than one point? You say no. Okay, so does it have an inverse? Yes. If it passes the horizontal line test, it has an inverse. So exponentials have inverses. Look at the horizontal line test here. Lines. Okay, lines. These are the 3 we studied. Lines. Does a line have an inverse? Yes. Look at this one. Horizontal line test. Did it cross more than one point? That's not really horizontal. No. It failed the horizontal line test because there's 2 points. For example, at 2, when y is 2, x can be 2 different values. Okay, so what passes, what has an inverse? Exponents have an inverse. Linear have inverses, but parabolas or quadratics do not. Quadratics do not have an inverse. So this is why we're studying inverses right now. We talked about it. We solved these problems before. On linear, we just never called them inverses. Well, we're calling them inverses now for exponents. Okay, we didn't have to worry about it on parabolas because parabolas didn't have an inverse. So remember, we started Unit 2 or Unit 1 with linear, and we solved these problems before. You should look at these type of problems back here and be like, oh, yeah, we solved those before. There's linear. And we never talked about it with parabolas. Remember, we did say f of blank equals, say, 2, and we said, oh, don't forget, there's 2 answers for that. Refresh your memory on that. You say the people say, oh, there's 2 answers right there. But exponents is big for inverses. There's big stuff for inverses because it's very difficult to find these values. For example, when is it 8? I don't know. Maybe at 2.7396, some weird number. That's why we're going to need the inverse functions for this. Okay? I think this was a lot today. I think we'll be okay for today. All right, so remember, okay, we have, don't forget to take attendance today. This week, your assignments were you have to turn in all these sheets that we went over. So we went over a couple sheets each Tuesday and Thursday. And the answers are posted online. So perfect time, perfect example to get all your work done and get it turned in. So you got to submit that on Schoology. And then quiz tomorrow. There's going to be a quiz tomorrow. Okay? And then I'll put grades in and we'll check to see how everybody's doing. All right, everybody have a good day, everybody.